Good afternoon. I'm Peter Thompson, co-founder and CEO of LucidLink. Today I'm going to give you a brief background about our product. For the past 3.5 years, we've been addressing the challenge of accessing files over distance and how to mitigate the latency involved in doing that. Our streaming file service allows users to access these files where they are stored in place and then streaming them on demand instead of downloading the entire file first or synchronizing entire data sets. We provide this capability as a service. We deliver it in software, and we allow customers to bring their own storage, whether that is physical on-prem storage or whether that is out of a cloud provider. And we implemented this on top of object storage so that customers can reap the benefits of object storage. So today we'd like to introduce our technology to you. We're going to show you a demo of it in action, and then we're going to dig into the underpinnings a little bit about that. The architecture describes some of the decisions we made, why we made those decisions, and why we think it matters. Since before we even officially launched the company, George and I started talking to customers. And after hundreds of conversations, it became pretty apparent some trends we were hearing over and over again. The first of which was that given this backdrop of just the eye-popping growth of unstructured data, and at the same time the file sizes associated with it were getting larger and larger, initially we heard people talking more about object storage and later on actually implementing it as part of their practice. And for good reason. It's very cost efficient, it's elastic, so it grows on demand, is easy to manage, and it's highly durable. But there's no file system that's associated with it, and it was never meant to be a transactional high workload type of storage. So customers were unable to run file-based workloads in production, although it was a fantastic place to park data for long-term retention. Secondly was the adoption of cloud services, and especially the ability to spin up compute wherever you needed to access it. And what we saw was that workflows began to spread out. So maybe they were creating or ingesting data out on the edge, would move it into the cloud because, well, maybe they had to spin up a number of GPU-enabled VMs to do a parallel processing workload like a rendering job or something like that. Then go back to to their desktop or workstation for some post-processing, finally to a manager for review or customer for for consuming it. So you had the ability to spin up these compute resources and point applications around and move them around at will. But then getting the data to follow those around and using them at those locations really was a challenge. And not only is the work flows that were spreading out, but also just the workforces. Modern companies today allow workers to work from home, shared office spaces, branch offices, more use of consultants and freelancers, and so and even through just mergers and acquisitions and company consolidation, the result is you had many more people collaborating on the same set of data and being able to provide fast, rapid, and secure access to that in a timely manner became a problem. And so this is where LucidLink comes in. Our product, File Spaces, is a cloud file system built specifically for object storage. Companies can create a shared global namespace that's accessible from anywhere with an internet connection. Devices that are in that namespace install the LucidLink client, and this gives them a file view to the data that's stored in the object storage. Now note that the actual files continue to exist in the object storage, but the applications are able to see the files as if they're local. Then, as they start requesting data, we stream it on demand as it's being requested. You'll also notice an absence of additional infrastructure here. This is delivered in software, and there's no requirement for gateway appliances or caching devices or complex networking. We put a lot of effort into making sure that it was universal, both from the front end as well as the back end. So you can see that we support all the major operating systems, and the client is able to run on virtually anything, whether it's servers or workstations, laptops, virtual machines, even containers. We also made it universal in the back end. We support any S3 compliant storage, whether that is on-prem hardware in your own data center or installed somewhere. So this would include companies like Cloudian, Scality, Wasabi, or any of the major manufacturers who have object storage offering, and most of those are S3 compliant. It also supports a cloud, so you can bring your own account if you have one with one of the public cloud offerings, whether that's AWS or Google, Alibaba, IBM, Wasabi, and we'll be releasing support for Azure later this year. Finally, we took a very strong approach to security. We implemented a system-wide, end-to-end encryption model where the client has the key, and so at the point when the data is actually committed, that's when it gets encrypted throughout the entire life cycle of it. So this is in contrast to a lot of services that offer encryption at rest. But with the client-side encryption, we feel that this is a much stronger model. As we were talking to customers and they were trying it out, we began to implement features that they were requesting from us. The first one is the streaming access. Again, now that's part of our core product, and I already talked a little bit about that, but it's really important because it changed the way that some customers were able to think about the way they use cloud. And an example of this is if you had a 10 gig video stored in S3, AWS S3, and I've got Adobe Premiere here on my laptop or After Effects or whatever, and I wanted to edit just the middle couple of frames of that video. Normally I'd have to download the entire 10 gigs, use it, then write it back up as a new object, and the next person who wanted to use it had to wait for that to be done, and then they would have to go through the same process. Well, with LucidLink, because of the distributed streaming technology, we can give Adobe or any software package the view that that file is local. They can mount it and begin using it, and then we stream the parts that it's required as it's being required. The end result is that rarely do you end up having to transmit the entire file, so it's really efficient. We also as more customers started putting work groups, they started putting additional users, using contractors and freelancers. They wanted to be able to segment their file spaces, providing specific access to different parts of it. So we implemented that. Today it's implemented as core part of the product, but we're also getting a lot of requests for Active Directory integration, and that's also something we'll be releasing in the future. Snapshot support was very important. One customer said, you know, I've got object versioning, but I've got 100 million objects in my bucket. If I have some kind of a corruption or something, there's no way I can go and individually roll each one of those back. So our snapshot is actually a different approach. This is a point-in-time copy of the entire file space as it exists at that time. We implemented our file system as a log structured design. George is going to get into some of the things why we went about doing that. But one of the benefits of doing that is the ease at which then we can take snapshots without incurring additional overhead. And then finally, global file locking. And this is different. Now, of course, we implemented from the get-go the ability for people to collaborate on files and avoid contention and handle all of that. What we're talking about with this are specific software packages that require this as a feature, usually with very large models that need to be accessed from geo-distributed locations, such as Autodesk Revit, for example. So this is also something that we've implemented.
In your Autodesk example you have there, so if you've got multiple people in different regions, drafting people, they're all trying to work on those things, you can allow them to work off of their local repository version and get that true kind of locking so that they don't run into those kind of collision issues that we all know so well. Well, at least, that's a big problem we've been facing forever with very little way to, good way to overcome that.
Yeah. Autodesk Revit and other applications, I'll talk more about it later, employ file locking, and we've implemented global file locking, and that exactly opens up for these geo-distributed use cases.
So what I'd like to, please.
And you only support object-based storage on the back end, right?
Correct. That's correct.
Anything else, block or anything?
No.
Okay,
Object.
specific to that.
Yep.
And real quick, and I just want to say this because, well, years ago, there was a Hitachi product that you may be aware of, right? That did similar things at the edge. Obviously, it didn't support object storage at that point. So,
Do you want to?
I don't know the
I can't remember.
for me to comment.
Maybe Hitachi. Does anybody that storage? So they used to have these on ramps that would go in branch locations, and it was the same thing. It was literally access the data, use it, and it only pulled down the bits.
Right.
Well, I can comment in general. I don't know how many years ago that was, but the reality is that the internet
10?
infrastructure wasn't there.
Absolutely.
Even 10 years ago. And the internet infrastructure has, advanced to a point where this has become practical, right?
Absolutely.
So even back in 2008, that was a little bit ahead of its time. But now we've reached that point where, we have gigabit connections and in some cases 10 gigabit connections, right? That allows us to do the streaming, right? Over a 10 megabit connection, you're not going to get that much.
Absolutely.
Right? So you're still.
That's cool. I mean, that's what I was sitting here thinking. I'm like, wow, they were really ahead.
Right.
Yeah.
So anyway, good stuff.
Yeah, and that was one of the insights that we had when we looked at all what was out in the market and some of the different approach, but similar type of products or distributed file systems and things like that. And George is exactly right. The advancements that we've seen is one of the key things that we're actually lucky we didn't start building it earlier.
Yeah.
Because you'd be locked into certain technologies that you try to adapt to today's infrastructure, and that's harder to do.
Yep. Yeah, and of course it required the Hitachi system, but total different model, similar concept, very cool.
Software only too.
Yeah.
So what I'd like to touch on now are some of the first the kind of high-level use cases of how customers are taking this technology and implementing it in their own practices, and sort of the journey that we've found for them coming in to us and how they've started to adapt it. After which we're going to actually show you a demo of it in a live demo of it in action.